Hello. In this discussion, we'll be continuing trig functions, and more specifically, trig functions of any angle. Now, in the previous videos, we've talked about evaluating trig function at special angles. Now, it's going to be at any given angle. So find the exact values of trig functions for any angle. All right, so this is one of those things here at tables that you just need to probably pause it for a sec. I'll read it real quick, but you need to pause it at some point and write it down in your notes. So let theta be any angle in standard position, and let AB denote the coordinates of any point except the origin, 0, 0 on the terminal side of theta. If r is the square root of a squared plus b squared, denotes the distance between the origin and that point AB. Again, you find that by the Pythagorean theorem. Then the six trig functions of theta are found defined by the following ratios. Sine of theta is b over r, cosine of theta is a over r, tangent of theta is b over a. And then the remaining three are the reciprocals of the three above it. Okay, so provided no denominator equals 0. And if a denominator does equal 0, then the trig function of that angle is undefined. So keep that in mind. You cannot divide by 0. So those last two lines of this table basically tells me I cannot divide by 0. So if one of the coordinates is 0, then it's undefined. That's another way to say that. So now this looks like it's going to be something new to you, and in a way it is, but in a way it's not, because this is really a right triangle. So if you look at the next picture, the same picture but form a right triangle there, so you can kind of go through the same idea. That's how they get what it is. So go back to that original picture, you look at the r, that's your hypotenuse. Okay, the height is b, and the length of the bottom of the triangle is an a. Technically it's going to be a negative number, but that's just a sign of what quadrant it's in. Alrighty. So remember, sine of theta was opposite over hypotenuse. So in this case, it's going to be the b over the r. Okay? That's how they got b over r over here. So it's opposite over hypotenuse. So using that triangle, it's going to be the b is the opposite side and r is the hypotenuse. Cosine of theta is a over r because that's adjacent over hypotenuse. The only difference here is that r is positive, but the a and the b may not be, because a and b are just coordinates on that terminal side. So if you're in the second quadrant, b is actually positive, but a is negative because you go left and then up to get in the second quadrant. So a has to be negative here and b has to be positive here. So you can evaluate a trig function and it turns out to be a negative number. So sine of theta is still opposite over hypotenuse, but it's b over r. B and r are both positive. So sine of theta will be positive in the second quadrant. But cosine is negative in the second quadrant because it's going to be a over r. And a in this quadrant is negative. So cosine is actually negative in that quadrant. So, and then you can make the same arguments for the rest of the six trig functions. The tangent would be what? Opposite over adjacent. So that's going to be b over negative a. Well, actually it's b over a. And because a is the distance between the bottom part of the triangle. But again, a is negative, b is positive. So if you do b over a on this one, it's going to be negative as well. Because although b is positive, a is negative. So tangent will also be negative in the second quadrant. So it looks like sine is the positive one in this quadrant. Alrighty, so let's move on. We're going to find the exact values of the six trig functions of theta given a point on the terminal side. Okay, so find the exact value of each of the six trig functions of a positive number of theta if negative 3, 4 is a point on the terminal side. Now I know the xy is a picture in the first quadrant. Okay, But in this case, if x is negative 3 and y is 4, then that terminal side is technically is going to be in the second quadrant. So you have to excuse the picture on this one because the picture I could only find a picture that has this one in the first quadrant. So the terminal side is actually in the second quadrant. So the xy coordinate is negative 3, 4, which means, if you use the Pythagorean theorem, the radius is 5. So negative 3 squared plus 4 squared is 25. And the square root of it is 5. So sine of theta is the y coordinate over r. So it's going to be 4 over 5. If cosecant of theta would be r over y, which is 5 over 4. Cosine of theta is the x coordinate over r. So it's negative 3 over 5. And so therefore the secant of theta is r over x, which is negative 5/3. Tangent of theta is the y coordinate over the x coordinate. And that's negative 4 over 3 because the y coordinate is 4, but the x coordinate is negative 3. So it's negative 4/3. So therefore the cotangent is going to be negative 3 over 4. Now again, I want to reiterate that this angle really needs to be in the second quadrant because negative 3 comma 4 is actually in the second quadrant. So if that angle is in the second quadrant, look at all of these ratios and look at the ones that are positive. It's only the sine and the cosecant. All of the other 4 are negative. All right. Now what we're going to do is find the exact value of the 6 trig functions find the exact values of each of the trig functions of 0 and 90 degrees. Now 0 degrees, remember, is the x-axis. And the point is 1, comma 0. And then using your argument, whoops, sorry. What we do here is the sine of 0 degrees, the y coordinate, over r, which is also 1, by the way. And that's going to be 0 divided by 1, which is 0. Cosine of 0 degrees is the x coordinate over r. And so that's going to be 1 divided by 1, which is 1. And you can do all 6 of them this way. Now, the reason I'm not showing it to you here is because this is all summarized in a table that's coming up. But what you could do, if it's 0 degrees, you could do every one of them. You could do the tangent is the y coordinate over the x coordinate. So it's going to be 0 divided by 1, which is 0. And then do the rest of them. Now, I do want to draw your attention to part B, though, here. If it's 90 degrees, it's going to be the sine of 90 degrees, which is the y coordinate over r, which is 1 over 1, which is good, 1. Cosine of 90 degrees is going to be x coordinate over r, which is 0 divided by 1, which is 0. But look at the next one. Tangent of 90 degrees. Tangent of 90 degrees is the y coordinate divided by the x coordinate. So it's going to be 1 divided by 0, which makes it undefined. So that's your very first one that we've talked about, that you evaluate a trig function and it's undefined. And it's because when you're dividing by 0, you cannot divide by 0, so that makes it undefined. So whenever the ratio has a bottom number that's 0, it's undefined. So that's when it happens. All righty? And you can do the remaining 3. The next slide we'll do the 180 degree one and the 270 degree one. But it's very similar, looking at the pictures. And so again, sine of 180 degrees is the y coordinate over r, in this case 0 over r, which is 1, which is 0. But like I said, these are all going to be summarized by this next table coming up. So I didn't put the individual ones on here because it is right there. Okay? So you have 0, pi over 2, pi, and 3 pi over 2. 0 degrees, 90 degrees, 180 degrees, and 270 degrees. So the sine of 0 degrees is 0. Sine of 90 degrees is 1. The sine of 180 degrees is 0 again. And then the sine of 270 degrees is negative 1. And you can do that for every one of them. But look at all those ones that are undefined in this table. Let's take the one that's the tangent of 3 pi over 2. Well, the tangent of 3 pi over 2, remember, that's 270 degrees, is going to be a negative 1 divided by 0, which makes it undefined. So you can put undefined, not defined. Yeah, that's the same thing. That's no big deal. So you can either write not defined like they're doing, or you can just write undefined, whichever you like the best. But a lot of those that are not defined, every one of them actually, the y coordinate, the ratio on the bottom will be a 0 on the denominator, and that's why these are undefined. So this one is one of those, again, this table right here that you just need to pause this, write them down, and just try to memorize them the best you can. You don't use them very often. I will tell you that, except when you're graphing them. So you'll refer to them long enough to complete the graph. And then once you get the graph done, then these kind of come obsolete because the graph will give you those values. So we haven't got there yet. The graphs are coming. We're just not there yet. But right now, just pause this and write these down, and so it'll be in your notes. And if you have any questions on this, let me know. And you have a good day.